Okay. The title is Sensitivity Analysis of Potential Host Dallas High-Speed Rail System, or the only focus on the environmental impacts. If we talk about the sensitivity analysis, sometimes it's a lot of parameter concepts or the factors. For example, safety, economical, corridor is the highest priority. From the map, you can see the Texas triangle has the highest estimated population growth. Also, in some reports said even maybe in 2050 the population in Texas may be double. The Dallas and Houston are the two major cities that is for the industrial activities, and all it causes the most non-attended countries of the ozone pollution. I think many people heard the ozone pollution. If air pollution from the industrial sector or from the power plants, from vehicle, in big cities, in California, Texas, that is cause some problem of ozone pollution. But if we have the problem in Houston, that is so on. That is the Texas, in Texas, Dallas and Houston, the city councils recently take steps for construction the 240-mile high-speed rail system to connect two cities. From previous studies, we know we learned that the high-speed rail system has the minimal release of regulated air pollutants and greenhouse emissions. If the HIFR was built, they would definitely the benefits for the air quality in the Houston and Dallas area. It also mitigate the demand of the traffic in the I-45. When we talk about because we know high-speed rail always rely on the electricity, we need to know that most of our electric generation power plants are located within the Texas Triangle region. It means convenient for provide the power to the high-speed rail system. For a new or a big or large project, when it's going on, we need to do some economic analysis or environmental analysis. LCA or the environmental called the overall environmental impact is required for the large system to do it. We generally do the life cycle assessment. Life cycle assessment is one of the most effective methods to estimate the environmental impacts and evaluate the mitigation methods or technology. Generally, for the LCA, for the emissions, that is the counts is from we call the lifetime of the product. In this project, you can see the products, the vehicles, and the highway. That is the high-speed rail tracks, the rails and the stations. Include the different phases: raw material extraction and processing, manufacturing and construction, the vehicle operation and maintenance, even the rail maintenance and life. For it means the everything that is the recycle. There's in last century at the time in 1999 they conducted the basic LTE the survey by the I think the department DOT US. They did compare the high-speed vehicle. They found the most environmental impacts contributed to the vehicle operation. Later on, after 10 years, researchers in California University of California. They did the high-speed rail system study in California. They found the also the major contribution are from the operation for the vehicle operation high-speed rail. They in the range of 70 to 90. Other Chinese researchers here, they did the high-speed rail system in China, include the vehicle manufacturing, the rail construction, vehicle operation, and disposal of vehicle and infrastructure material. Because their study, the vehicle will be fabricated in China, they didn't include the transportation phase. In our study, for our study, the life cycle LTA study, we conducted follow the ISO 14040 and 14041. You can see from here that is we got the imaging that is the picture created by the company. You can see how it looks like the high-speed rail system will be. In our study, you can for the life cycle assessment, the one very important concept is system boundary. You can from the figure we can see it includes the vehicle, the top part of the vehicle, and the bottom part of the infrastructure. Vehicle is the raw material reaction processing, and the transport to the plant fabricate the vehicle, and after vehicle get and then transport to the operation location. Here is from the Dallas and Houston station, and then finally go to the end of life of the vehicle. For the infrastructure part, is we have the raw materials and then transport to the production location, and then transport to the other, and still sometimes use the transportation to the location and Dallas and Houston, or along the rail, and then finally end of life disposal and recycling. During this process, we need the energy, water, and some raw materials. It means also during the activity we have the air, water, and emissions.
Hi, Hongbo, and just letting you know that you have 3 minutes left.
I don't know what's the reason why it runs so. I just click it and then run so fast. That's no. I just use the up and down the. Or I just do like this way. Do you think that's okay?
Yes, yeah, that should be fine. We can still see your slides.
Yeah. Okay, like this way is better. We are using the database is the equal event v4, the process in the SEMA Pro. It's included the default HSR system. And the other for the specific data electricity mixture, at first use the US mix, electricity grid mix, and then later on we use the Texas data. The current condition we have we compared the operation with the cars or the bus and also the aircraft from Dallas, Houston. Generally, another other concept, basic concept in the life cycle assessment, we need to know the functional units. For the we majorly use the two is the vehicle kilometer traveled, and another one is passenger kilometer traveled. You can see for the passenger vehicle traveled, we use the following equation that do the calculation. Another thing we need to do is called the middle point calculation. Is the equation we get it from Pro and use the equation to the vehicles infrastructure. Use the equation 2 and 3. Because this high-speed HSR is not built yet, we have to also based on some knowledge is missing. We have to do some assumptions. If we suppose the vehicle is, will be built in Japan, also another thing that is for the raw materials, energy use, and the on-site transportation, we use some data in the Pro database. For the track choice is non-ballast with viaducts and bridges above the level, and that is the most people do. Most high-speed rail in China are doing like this way. The end-to-end route is 240 miles.
Hangbo, and just to keep ourselves on track, you have 2 minutes left.
Oh, that's awesome. Here the results we have. You can see middle points. We have the visualizations or the others. You can see from vehicle operation. We have for something we have high. For the infrastructure takes a small amount, and when we go to the energy, you can see for the energy, the vehicles for the fossil energy it takes more, and the infrastructure takes the similar, but some of negative data shows that we are using the renewable energy. Here is the life cycle emissions. You can see compared to the cars, bus, aircraft, the HSR system has small emissions for the global warming, but when you see the PM particle matter, that is go to higher. The reason because it's using more, much more electricity. We know the electric power plant is the major contributor to the PM. For the sensitivity analysis, majorly we did the comparison between when we use the Texas grid electricity mixture and the US. When we use the Texas data, we can see these emissions that reduce a lot. And for the others, for the other transportation mode, it looks better for the greenhouse emissions, but for the PM is still high. You can from our data, you can see the operation maintenance increase the most in the overall vehicle emissions. The current US and Texas doesn't that is actually not in the Pro yet. We have to do ourselves. For the final conclusion, for the Pro, you can use the middle points to do your analysis. That is include 15 categories. Vehicle counts the emission like this is the primary for the GHG emissions. For the infrastructure, GHG emissions go to majorly come from the material injection and processing phase. For the vehicle operation and the electricity consumed in that stage, that is determining the environmental efficiency for the HR system. Barely for the PM 2.5. If we increase the renewable energy use for the wind power or solar power, it's more benefit for the region. Yeah. Finally, we also thank for the funding support by the Tran-SET and also partly from the FF for the Quest Center support. That is, if you have some information, some questions, you can ask or contact our my supervisor, Dr. Konopati. Thank you.
Great. Thank you very much, Hangbo. And we have a few minutes left for questions. Does anybody have a question for Hangbo? Any questions for Hangbo?